using them in the system specification part. Today we continue with the single line diagram, and I'm gonna jump over to the presentation. And cover what we talked yesterday. So we did talk about SCL language, and we'll repeat that in few words. So objectives of today's training are to create new project, to draw single line diagram, to specify and allocate logical nodes, attach documents, and then to deal with some features like copy and paste elements, base. We'll show how to export into SSD file and how you can, in the future, import template files into the SCL matrix. And we'll also cover substation section SCL structure and some color scheme that you can use. We talked about file types: ICD, IID, CID, SSD, SCD, SCD. We covered that yesterday. IID and SCD files are the type of files that were introduced in addition to of the standard. And this is the engineering flow. 6150-6 part of the standard specifies engineering software to be used in this process. The first is excuse me. The first is IED configuration tool. That's a tool of the relays. The relays have a software that is capable of producing ICD file. These are template files. This is not configured, just the template files that show capabilities of IEDs. That's the extension, IED capability definition. These ICD files are imported into the system configuration tool, and system configuration tool performs two actions with them. It creates the horizontal and vertical communication, the data flow engineering. It configures the data sets to be used. It defines goose and sample value process bus, publisher subscriber, and client server MMS. There is also system specification tool, SST. That tool is responsible for creating the single line diagram and allocation of logical nodes from either virtual or ICD files within the single line diagram. SCL matrix is both system specification and system configuration tool. So with this package, SCL matrix, you will receive both system specification and system configuration tool. During the process of the configuration, the system configuration tool, SCL matrix, will create SCD file that will be imported back into IED configuration tool. The IED configuration tool will then complete configuration of IEDs and will produce downloadable CID files. Now, in addition to performing 61850 configuration, IED configuration tool will also allow you to perform other configuration parts related to either protection or to control and automation. The final file CID is downloaded to IEDs, but then IED configuration tool also supports generation of so-called IID file. These are the files that have all the instances of the 6150 instantiated, and that file can be uploaded to system configuration tool so that SCD file is upgraded with these individual IED settings. That is the file that you keep, and that's the file that represent your system configuration. So we'll cover now this part, which is related to system specification. That means we're going to go and create single line diagram, and we'll use logical node to allocate throughout the single line diagram to present what control and protection functions are to be used in the system. So you can start your SCL matrix by starting Engineering Studio. I'm going to do that. Engineering Studio, and I click on SCL matrix, and that should invoke your SCL matrix. I had it open, so I'm just going to close. So this is what you should see, the start page of the SCL matrix. Start on a new project, and this time you can select Edition 2 project, and you can call it Single Line Diagram Training. Click on Create, and that will create your new project. Obviously, we don't have any IDs imported. We have nothing. All tables are empty. Now, generally speaking, when you use SCL matrix is organized by tabs, as you can see. There is a start page, and then there is a SED structure page. That page shows structure of IEDs imported into SCL matrix. At the moment, we don't have any IED imported. And then you move tabs from left to right. This is how you follow your configuration. You're going tab by tab to perform the entire configuration process. And each of these tabs might have tabs at the bottom. So you need to go again from left to right to complete each of these sections. So you start page, SED structure will show your IEDs. You can see the IEDs in the tree view. Right now it's all empty. And you can also look at the configurable values of template files that you import. Then you start with a single line diagram, which is
grid software. Có cái grid software này. Đâu bọn nó trên ninh mà xem. Nó là cái phần mềm 61850.
Okay, I'll continue. So in single line diagram, you have a tool set of your single line diagram components, from substation, voltage bay, transformers, disconnectors, circuit breakers, cap banks, reactors, and so on. You will use them by dragging and dropping onto the pane. That's how you do drawings. We'll do that. And later we'll show how logical nodes will be presented here. When you finish with that, you are done with system specification. You move to communication engineering, where you first go through services, subnetwork, and access point. You define all these, and then you go to communication diagram, where you can draw COM block diagram of your system, define all physical connections, and then you go into the data flow engineering. That is major part of the system configuration process. You will deal with data sets, you will configure data sets, and then you will start configuring control blocks, clients that are communicating control blocks, Goose control blocks. So that's Goose publishing, then Goose subscribing, what IDs are subscribing to Goose messages. Same for sample value control blocks, publishers, sample value subscribers. If your project requires logs, logs will be defined here as well. And the final input table will be automatically populated with the points that are coming into IEDs, whether through Goose or sample values, or for the clients through client server MMS. At the end, you'll be able to draw this diagram that visually present how the system is configured. In our presentation, perhaps we'll start today, if not tomorrow, you can use this data flow diagram to perform configuration, and so that you don't have to use this tab, all these tabs. So it's up to you. What's your preference? You can either visually use this visual tool or go through the tables. Okay. So now we'll skip SED structure, but because at the moment we'll not import IEDs, we'll focus on drawing single line diagram. That is the main goal. So we created new project, and we clicked on single line diagram tab, and that's where we are. Single line diagram. This is the space. This canvas is a space where you're going to draw single line diagram. Now, when you draw single line diagram, there are rules that are defined by the standard, and our software follows those rules. So, and again, like in IED Builder, you will be guided what must be done in each step, and you will not be able to create something that is incorrect. You will either have option to draw or configure, or you will not have that option. If you don't have that option, you will be prompted that you are missing, or you are doing something that is not allowed. I will go to that. Come back to that. So this is the workspace single line diagram tab. And basically, the first thing is we will drag and drop the substation element from the toolbox area into the canvas. So every system specification must have substation. That is the mandatory part of your system specification. So I'm going to grab substation, and I'm going to drop into the canvas. When I do that, you will see 3 boxes. This is because there is a rule that says if you are creating a substation, every substation as an object must have a voltage level, and every voltage level must have a bay. So these are the mandatory part that our software draws automatically. So again, when you drop substation, you will get not only substation, but you will also get voltage level and bay. Now, the next step, we will drag and drop bus bar element from the toolbox to the drawing area. So bus bar, let's grab bus bar here. Before I do that, there are 2 standards how the substation objects are drawn, and I'm assuming that you are using IEC standards. This is just a difference in how the objects appear on your drawings. And don't worry, at any point you can switch from ANSI to IEC, and that will be automatically changed. So I'm going to take a bus bar. I'm going to drop onto the area that is allowed, and that is to the voltage level. Okay, so I was trying to drop bus bar in previous action. I was trying to drop bus bar to bay area, but the message says bay element can only contain conducting equipment, power transformers, or connectivity node elements. So basically, bus bar is part of the voltage level, and as such has to be treated. Okay. So bus bar is added. And I'm going to make possession of these boxes as on this image. And I'm going to click on substation and add name EE1. So these are the names that are used by the IEC standards. They represent certain voltage level. In this case, EE1 represent the substation with voltage level, with the high voltage levels, and we're going to be using 400 kV. This is the standard called 81346. And standard 81346 hierarchically defines objects in a technical environment. Each level of hierarchy is combination of character followed by combination of ciphers resulting in naming uniqueness objects naming. So here at the bottom of this presentation, you might find some of the description for that. Okay, so I'm going to position this as shown on the drawing. So I have a bus bar, and I have a bay within a voltage level, within a substation. And I'm going to change substation name. I'm going to give it the name EE1. So there are different ways. You can double click on the substation, or you can right click and do modify, whatever it's easier for you. I'm going to call it EE1. And I'm going to double click on voltage level and enter designation C1. And again, I can use double click on here or right click on voltage level and modify. For the bay, we'll use name Q01. Oh yes, I'll start recording. Okay, thank you. So we'll call bay as Q01. Again, Q01. This is how you keep names. And as you can see on the left side in the substation pan here, as you add these names, they will show up on this pan. And you can always either select object on your pane by clicking on it or by clicking on this left substation window here. In the next step, we'll add another voltage level, and we'll name it D1, and we'll drop below this existing one. Okay, so I'm going to go and grab voltage level. Obviously, if I try to drop here, I will get error. Voltage level can contain only bay or power base performance, so it's illegal move. But if I drop within here, then this is allowed. I can manipulate this a little bit the way I want it. Just to make some symmetry. And I'm going to call this D1. And bay will be also called 01, Q01. It'll be 220 kV. So let's do that. Call bay voltage level D1. So capital letter D1. And bay, oh, so that's E1, sorry. E1. And bay Q01. And I'm going to add another bus bar here. The first bus bar will be 400 kV. The bottom bus bar will be 220 kV. I try to minimize this so that the entire image is shown here. Okay, next step is to adjust information found on the voltage level. For the top one, C1, we'll add voltage of 400 kV and make it three-phase with nominal frequency of 50 Hertz. So voltage level, modify. Number of phases, 3. Nominal frequency, 50. And voltage is 400 kV. Just a second, please. Okay. So for the bottom voltage, we'll adjust to 220 kV, same three phases, and 50 Hertz. So click on modify, 220. Number of phases, 3. Nominal frequency, 50. So this is important because when you are drawing a single line diagram, you want to have all the information being entered into the SCL file. So as you can see, as you walk through the model of the substation, through voltage, base, and conductive equipment, you will get physical values on them. These coordinates will automatically be defined by the software. You don't need to worry about them, but you want to have in your single line diagram all the values. Now I will start drawing some elements. Again, in this presentation, icon set is set for IEC, so that's good. It is in line with what you are doing in your region. So the next step, we'll drag disconnector, circuit breaker, voltage and current transformers as shown on this image. So let's drop each of them: disconnector, circuit breaker, voltage transformer, current transformer, and in-feeding line as shown on this image. So we'll drop disconnector, circuit breaker, current transformer, disconnector, and in-feed line. Another disconnector, and in-feed line. Okay, and we'll also add voltage transformer and another disconnector. Voltage transformer. And a disconnector. Okay, so again, disconnector, circuit breaker, current transformer, another disconnector, in-feeding line, voltage transformer, and another disconnector. In the next step, we'll click on the upper port of the disconnector element, and we'll drag to connect to the bus bar, 4 kV bus bar. So from here to here, that's how to make connection. And we'll also connect other elements as shown on this image. So disconnector with circuit breaker with current transformer with disconnector, disconnector with in-feeding line, and with voltage and disconnector. So you just okay. And from here, and from here, finally, we will add disconnector. We'll add earthing switch to the disconnector, and that's by selecting ground tool on the toolbar and by clicking on the bottom part of the element disconnector. So ground, and then click on bottom part here. Okay. So this is the image that we drawn, and we'll repeat that, and we'll rename everything according to this image. So first disconnector is QB1, circuit breaker QA1, current transformer BC1, another disconnector QB9, BC9 earthing switch BA9, voltage transformer, and overhead line for the impeding line. So let's do that. QB1, QA1, BC1. So QA1, QC1, QB1. I believe that's what it was. BC1, sorry. QA9. QB1, QA1. QA9, QB9, overhead line, Now, obviously, you can use your naming convention for your element, but I'm going to follow the presentation: QB1, QA1, BC1, QB9, overhead line BA9, BC9. The QA1, this is 400 kV, so we're good. I'm going to go to next slide, and we'll show how you can quickly copy and paste the entire bay. So once you draw this bay, once you name it, you can save your time. If you have same type of arrangement in your substation, you can do copy and paste. And let's see what's going to happen if you do copy and if you do paste. As you can see, you can easily expand your single line diagram. All you need to do is rename a connections, and you have your another bay. Again, you right click on the entire bay. You can actually copy a bay, you can copy voltage level, you can copy substation. Everything works in SCL matrix. You can quickly replicate things. Okay, this was just the exercise, and I'm gonna, for this purpose, remove this, delete that. This was just to show you how you can remove or add new elements on your single line diagram. Now, between the voltage levels, we'll add the power transformer, and in this case, it's a 2-winding transformer that is located on the drawing object pane, and we'll stick in the middle. So 2-winding transformer we'll add in here. And then we're going to focus on adding these elements as shown on this image. So we'll add another bay in 400 kV voltage level, and we'll populate on the bottom voltage level elements as shown on the image. So let's go with the top. We're adding disconnector, current transformer, and circuit breaker. And we're adding shunt reactor, or sorry, surge arrestor. So we'll add new voltage level, sorry, new bay. And within the bay, we'll add disconnector. We'll add current transformer. We'll add circuit breaker. And we'll add surge arrestor. And we'll do the same at the bottom. Circuit breaker, current transformer, disconnector, surge arrestor. We'll just shuffle this a little bit here. We'll bring this power transformer here to be in line. Now we'll add this so adding disconnector. Current transformer, circuit breaker, and surge arrestor. Okay, let me see if I got that right. So disconnector, current transformer, circuit breaker, surge arrestor, power transformer, circuit breaker, surge arrestor, current transformer, disconnector. We'll just move this surge arrestor on this side here. I will now make connections. So this connector to 400 kV bus bar. We'll make these connections and we'll connect circuit breaker with transformer, a low voltage side of transformer to circuit breaker with current transformer with this connector, and to 220 kV bus bar, and we'll also connect surge arresters. So let's do that. So you got this connection, we got that connection, we got this connection, and we got that connection. And we got this connection. Now on the voltage side, we connect this connector with current transformer with circuit breaker. Oh, mistake here. I have one more disconnector, that's fine. But I need this connector here. And this connector to bus bar. All right, so at the end, you should end up having image as shown in here. I have one too many disconnectors, so just gonna fix this and make it as per the image. So I actually have circuit breaker here. And then current transformer. Yeah, that should be in line with the drawing. Oops. I'm gonna jump. Are we okay? Are we guys following this? Are we okay with the drawing? We'll just we'll rename the elements as per this drawing: QB1, BC1, QA1, QB1, QA1, BC1. These names could be the same. Actually, they need to be same. If you are following the standard, the only thing that will change will basically be bay. So the bay itself will make the difference, and that bay will be Q02. Each of these numbers actually represent voltage and location and the element being used. Transformer will be TA1. And at the bottom, we have, again, the same QA1, QB, BC1, and QB1 with QO1. QA1. I have it wrong. I apologize. Here I should have QB1, BC1, QA1. So this should be BC1. BC1, QA1. This is QO2. This should be QA1. This should be BC1. And the disconnector is QB1. And obviously this is also QA1, but the difference is that it belongs to voltage E1, and for that reason it is correct naming. Now I'll just go and expand this a little bit so that I can show you again capability of the software. You can copy the entire voltage level. You can paste voltage level with all base inside. That's one option. So again, right click on voltage level and you paste it on the substation level. You also have option to copy and paste, and I show that to copy and paste just the bay. So you're going to copy bay and paste it in here. So this is how you can speed up your work on your single line diagram. On the right side, you have all elements that you need to have for the drawing, and that's how you draw your single line diagram. Okay, I'm not going to spend more time on the drawing. This was just to show you capabilities of the drawing software that is part of the system specification. Now we'll go and we'll start dealing with the definition of protection and control functions that are tied to your elements, to your disconnectors, circuit breakers, transformers, and so on, all the lines. So you can add, obviously, you can add logical nodes to it so that you describe what protection and control functions you're using. And again, if you are not fully familiarized yourself with 61850 standard, then it's time to refresh on the concept of logical node. Basically, when the standard was developed, it was developed with the idea that every single function in the substation be represented by a model representative. For that reason, all the functions are numbered, and they are decomposed into the smallest entities. These entities are called logical nodes. So one or more logical nodes will represent a well-known protection, control, or automation function that we have in the substation. These logical nodes are organized in the standard under the 61850-7-4. That part of the standard defines logical nodes that are grouped in several different groups based on their functionality. The one rule is that every logical node is represented with 4 letters, 4 capital letters. These letters could have prefix and suffixes at the end, but these 4 letters allow software tools to automate their process to recognize these objects, these models. Every logical node belongs to a certain group that starts with one capital letter. This is just for organizing. As you can see here, there are examples of logical group M, which is logical group that lists logical nodes for metering and measurement. Logical group protection functions is designated with letter P, and within the protection functions, all these functions are listed with their 4 letters. These are some examples: differential, distance, protection scheme, time over current, over voltage, instantaneous over current, and so on. Letter X is for switchgear. Examples are circuit breaker, circuit switch. R are protection related functions. Examples are breaker failure, fault locator, auto reclosing, and so forth. So our goal is basically that we use these 4-letter designations that obviously represent the smallest functional entities in the substation, and to spread these logical nodes throughout the single line diagram so that we can explain what functions we want to see in this system. And obviously, when we go to the breaker, we want to see breaker fail protection. When we go to line, we want to see line protection combined with the breaker protection. When we go to cap bank, we want to see cap bank protection. To shunt reactor transformer, we want to see transformer protections, and so on. So right now, the single line diagram just represents my substation, but it doesn't tell me or doesn't tell anyone what functionalities, what protection and automation functions should be implemented. And for that, we have second part of the system specification process, which is allocation of logical nodes. That is the next part of this presentation. So you have several options. One, the quickest one option is to use embedded logical node builder that is found in this system specification tool. So for example, in this presentation, we click on this connector and we describe what functions should be associated with this connector that could be motorized or not non-motorized. So we click on the disconnector and we click right click, and we have option allocate logical node. When I click on allocate logical node, I have a list of all logical nodes available in the standard, and now I'm choosing from one of these logical node groups: automation, control, supervisory, distributed energy resources, protection, metering, protection related functions, switch gear, and so on. For this connector, we're going to allocate logical node X switch first. So let's locate that logical node. It is under the switch gear. It is under X switch. So X switch, if you go to the standard, basically X switch is a circuit switch or disconnector. So that is the logical node that will hold status information about your disconnector. It's open, close, and so on, how many time open, and so on. So you can relate to the standard, and I'm going to open standard for that purpose, just to illustrate that better. I'm going to go to edition 2, 7.4. And I'm going to look for logical node X switch. Now this is where the logical node is defined. And here it is, explanation of the logical nodes. This logical node is used for modeling switches or disconnectors without short circuit breaking capability. For example, disconnectors, air breaker switches, earthing switches, and so on. And if I look at the information here, this is the type properties of X switch class that are associated with this logical node. As you can see on the right side, there is a designation mandatory, optional, or conditional. There are three mandatory information about this logical node, and that is local control behavior, operational counter, and switch type. All others are optional. Now, when you go to system specification tool, you can select this circuit switch. You can give it a name. Let's see what is used in presentation. Okay, it's used default name, and you click OK. As you click OK, you can see this plus sign that you can expand. And this plus sign shows that this disconnector requires functionality described by logical node X switch, and also describe that this disconnector, this logical node, currently does not belong to any ID. This is the prefix none. Okay, that's very important because it's vendor neutral. So that's one way of allocating logical node, and we'll go and follow the exercise. I'm going to just jump into the to explaining, which is outside of presentation, explaining what else you can do to define these. You can basically go and now import an SCL file that is not vendor, hopefully not vendor, but rather virtual. So I'm going to use this virtual ID from yesterday. Oh, this is edition 1. Sorry. I'm doing edition 2 project. Okay, I'm just going to make, I'm going to import different, I just have to look on my SCL files that I have. It should be in here somewhere, virtual. Here. Obviously, this is open file location. All right, so I'm going to import one of my virtual files. Virtual ID, that's what I'm going to rename it to. And now, because I have this virtual ID in my environment, I'm going to look to see if this has, so I can allocate logical node not just from this builder, embedded builder, logical node builder, but I can also use an ID, virtual ID. So I'm going to look and see if there is any C switch, X switch here. And I'm going to remove this one for the time being. Now, as you can see here, now I have allocated logical nodes, the same logical node, X switch, but this time it does belong to an IED, and it belongs to IED core virtual underscore IED. This way, I not only provide what logical node is associated with this disconnector, but I also give a real IED that has the real inputs. It has all the properties of the X switch logical node. And I can look at that in two ways. I can look at the system X switch, and here are the data objects. So these are the objects that relate to this standard. So this way, I not only said that I want X switch, but I was also specific in what type of objects from the list of mandatory and optional I want to see in this logical node. Again, here, virtual ID. When I export this virtual ID, when I export this single line diagram as SSD file, this SSD file will also have the virtual IED, and virtual IED will have will have the data objects and data attributes listed: nameplate, mode, position, black open, black close, block close. And there will be data attributes associated with it. So I could not be more specific in describing requirements of the function related to this disconnector. It has to be functionality that is described with logical node X switch, and it has to be data objects and data attributes as defined by this virtual IED. Now you can also obviously import vendor IEDs and use them, but the only difference is here we are vendor neutral, while in bringing vendor type ICD files, we would be asking, okay, we want vendor specific IEDs to be used. Now, we'll make a short break, but when we come back, we'll go and populate other logical nodes here. But point here is when you configure and you complete this allocation of logical nodes, they will show up here. Okay. When you give this single line diagram to a system integrator to do the job, then you have everything specified. You have a single line diagram, you have your protection automation functions described a logical node. And if you use virtual IEDs, you also have exact data objects and data attributes that must be matched. Then the system integrator would come here and would replace this virtual IED X switch with a real IED match. And we'll come to that later when we do last piece of system configuration, system specification. So in the next slides, we're going to be adding some more logical nodes here. C switch for switching, motorized switching of this disconnector, and interlocking. Under what condition this can be closed. And then we'll continue to add some more of these logical nodes to different elements so that you can get used to different logical nodes. Well, let's make a break, and we'll come back at 10:15. So that's in 12 minutes. We're going to make a short break. Do you have any questions, or we're okay for now? Okay, I'll see you in 12 minutes. delete this virtual one and just going to be in line with the presentation. Allocate logical node. X switch gear. And I'm going to add X switch. Then I'm going to add another logical node. It's going to be C switch. And interlocking. So this is the list for the first disconnector. If you want to know more about C switch and C interlocking, I can open that and I can quickly show. C switch is the logical nodes class that shall be used to control all switching conditions above the process level. It's subscribed to some protection related function and it's tied with XCBR. So if a switching command, for example, select before operate arrives on this particular point of wave switching capability, this is supported by the breaker. And then the command shall be CPOW and so on. So C switch and XCBR almost always work together. So does C switch and X switch. Now we'll continue adding logical node as described in this presentation. So we'll go to circuit breaker and we'll add XCBR, C switch, interlocking, RRIC, and RSync. So let's do that. So I click on circuit breaker, right click, allocate logical node. I will do XCBR. We'll do another logical node, C switch. We'll add C interlocking. And we'll add protection related function, auto reclosing. So here's the list: CBR, C switch, interlocking, auto reclosing. And sync. The synchronizer controller. Okay. As I add these logical nodes, the list of logical nodes here is getting populated. This is where the locations of these logical nodes are. These are the classes. Let's continue. Same for the QB9, X switch, C switch, and C interlocking. QB9. X switch. C switch. And C interlocking. Now, obviously, if you are describing CT and VTs, you also have logical nodes for instrument transformers. So you have voltage transformer and you have current transformer, TCTR. This is especially true if you are using merging units. Okay, I can add voltage transformer here. Same for this earthing switch, especially if it's motorized. Same logical nodes X switch would apply. For motorized, you would have C switch. And C interlocking. Now all these substation elements are defined. Now you can start defining your protection functions. And you can assign protection functions not only to the elements, but also to the base. What functionalities should be implemented in this bay? And obviously, since you have a breaker, there will be breaker fail, there will be line, distance protection, and so on. Let's match what is on this list. And on this list, I have time over current, directional, distance, 3 elements, and protection related function. So I'm going to add them one by one. We also have metering. That would come from your voltage and current transformers. So let's add them one by one. MMXU, PTRC, PTOC. And again, I'm tying this to the bay level. So start with the metering, MMXU. You can also use some other elements if you are using, for example, non-phase related measurement, you would use MMXN, but I'm going to use MMXU. So it's added, and I'm going to start adding protection related PTRC. Was it time over current first? Let me just be in PTRC, PTOC. PTRC, protection trip conditioning. PTOC, time over current. Directional element. And obviously breaker fail. And we're going to add 3 elements for distance. Instance 1. Two and 3. And if I expand, I will see the list of these logical nodes. Okay. So we covered all of them. I will show how to document. I'll give you a couple minutes to catch up and do the same. And I'll leave the screen for a couple minutes so that you have the same logical nodes mapped. Okay. Now, in addition, you can attach document that additionally describe requirements of certain elements. In this example, we're adding a disconnector specification document. I believe you should have it in the training material. Yes. So I click on the element that I want to attach document to, in this case, disconnector. and I say attach document, and I find this connector specification, and I can add the document. So now document itself is listed here. When I pass this project to someone else, basically they will see the document that describe this connector. Okay, so option is click on the object, attach document, find document that you want to add. This is circuit breaker, and almost all files are supported. The first one was PDF. This is Word document. This is a technical specification of a Word document of the circuit breaker. Okay. And again, at this point, when you have allocated logical nodes, that's where the benefit of copy and pasting is, because not only you will get copy and paste of your objects, you will also have copy and paste of your allocated logical nodes. All you need to do is make connection. Okay, so in this example, we are copying the entire bay, we are pasting the bay. And all we need to do is make a new name for the voltage, for the bay itself, Q03. Q03. Now, the last point is you save the project, and then you export into, we'll save the project, we'll export. Now, this version, older version of this, of the SCL matrix, that was our initial version, didn't have support for 2.1, and you will find that there was an option to export as SSD1 or SSD2. Now there are, with edition 2.1, there was a more strict rules tied to edition types. So if you are running project edition 2, now you will be able to export edition 2. If you're dealing with project 1, you will be able to export project 1 only, and for 2.11 the same. So I'm going to export SSD file, and I'm going to call it system specification training. Okay. Now, if I look at the logical nodes, now there is quite a bit list of logical nodes that we allocated. Basically, we have a system single line diagram. We have all the elements. Each of the elements is represented with intended functionality described through logical nodes. The bay functionality, protection, and control are described, and measurement are described with their logical nodes. So the system is completely specified. I have a question from one of you. Well, no, we can't do that because we don't have enough time. Again, I need to underline that this training was not intended to be a training. In normal training circumstances, we provide training on targeted equipment, and we include live sessions in which we provide live traffic with intended IEDs, whether this is Schneider, Schweitzer, GE, or other relays. This training here is not actually the training itself. It was meant to be the support for sales and technical team with very, very limited number of hours. Actually, number of hours that includes also technical help through the emails was 20 hours. One training for SCL Matrix is 40 hours. So we are covering the entire engineering studio in 20 or less than 20 hours. And for that reason, we cannot have anything that looks like a full-blown or complete training. So I need you to understand that this was meant to be a short, very short introduction of equipment, software that we provide for your sales and technical teams. It is not meant to be full training as we do with our clients. So for that reason, I have to limit my time because we have very, very limited time to show some of the features of our software. And I'm going to be now speeding up and jumping because time is running out and we don't have enough time. So for that reason, we cannot answer to your question. Could we have a live equipment, IEDs to demonstrate with the software? No. Tomorrow we will run a software, but this would be on the simulation and test software discovery and SimLab, but it will run on my computer and you will be able to see session on my computer. If you follow me, you will be able to recreate that on your side. Okay, let me see if there was other questions. You can actually type me a question in the chat window. I have no problem to answering your question. All right, so we exported into SSD file, and then we'll show how you can import certain elements of the single line diagram into your project or into your single line diagram. So after saving, I maybe just want to open this to show you the structure. Okay, so this is the file that I created. I can open with Notepad, and you can see the full structure of the SSD file. So you start with the substation section, and you have your voltage levels, and between voltage levels you have your transformer. So transformer elements are, we just zoom in, transformer elements are the windings, transformer name, other winding, and connectivity node. In the voltage level, we first have base. In this case, we have 4 base. Let's rename this one to, yeah, that's a voltage level. So we have a bay, and within the bay, we have a logical nodes, MMXU, PTRC, PTOC, and so on. Conducting equipment, disconnector, circuit breaker, current transformer, another disconnector, in-feed line, voltage transformer, disconnector. This is your substation section of the SCL file. All right. We said also that we can import certain sections. So I'm going to do import SCL file. And I'm going to use this sample substation. I'm going to use the same file that I created. As you can see, when I import this substation, it is basically this substation here. Again, substation is composed of 2 voltage levels, 3 bays, 4 bays. So if I want to copy, for example, this QO3 here, I can do copy paste. But if I don't have this and I want to have something like that from previous project, I can do import system specification training. Here I have options to select the entire substation. Give me just a second. Import. So I can import the entire substation as here. Just a second. Or I can No, I have to use different methodology. You have to import substation. Apology, this was the error. So I'm going to go back to my substation here. I use import substation. I use the same. Now, as you can see, I can import some or all of them. I can import the entire substation. I can select voltage levels, the entire substation or base. If I want to import this particular base, this is QO3. I select QO3 and I click on it. And here it is. So I was wrong. I was importing the entire SCL file. That brought me another substation here. And as you can see, you can hold multiple substations in your project. So this is another way of how you can quickly transform your single line diagram. Again, import substation. You can select one or multiple bays. Let's do QO1 and QO2. Okay. That's how you draw your single line diagram. Other options, you can rotate elements, delete elements, add sub-equipment functions, terminals, and so on. So these are just options on, for example, if I add this connector, I can play with it by rotating it. I can delete and conducting equipment, add general equipment. So they're all being added in this part of the pane. Okay, and again, this changes based on where you are. If you are on bay, there's a one option, set of option. If you are on the voltage level, it's a different set. And if you are on the substation, it's a different set. You can also use these here to copy, paste, delete, or allocate logical node. And again, once finished, you should save and export SSD. This is how you perform system specification. You give this file to the people who will be performing the configuration, and they know what you have requested from them. Yes, so I was mentioning this at the beginning. These are the IEC type of icons used. I can change them to ANSI. As you can see, everything will automatically be populated. So again, ANSI or IEC, two different standards or describing single line diagram. You can also change the background color. If you go into the home and click on settings, you can change the colors black, white, or orange. You can also change, go back to IC. You can also change these lines. You can also change your rounded lines and so on. This is just for appearance. Now, SEL matrix later you will see. The reality is that many IEDs don't have, actually have never gone through the certification process, or at least SCL files that represent them haven't gone through the conformance certification. In other words, I don't think there is one ICT tool in industry, this tool here, that has passed conformance certification. As a result, some of the files that we found are completely incorrect when it comes to 6150 standard. And at the beginning, our policy was if a relay file of a relay is not in line with the 6150 standard, we will reject to configure such file. But the reality was that there were so many files that were incorrect. So we created these exceptions that you can check to bypass some of the verification functions that our software is imposing. And verification is done by the 6150 standard rules. We're not implementing anything custom. It's all about whether the SEL file is defined as per the standard requirement or not. And these options you might use to deal with those files that our software reports errors. So in order to avoid having these errors and to be able to configure files that don't have IED models or ICD files that are correct, we provide these check buttons. Browser window is this left pane window that helps you in navigation through your object. You can either select object here, or you can look for the selection on this list. So as you can see, every time I select, this object will be selected. Now, there is also this project report tab. I was briefly talking when we were in ID Builder. It is available throughout all our software. And here, for this particular single eye diagram, you will notice that you can actually create printout of this file. You can scale this so that it fits on the whole page. You can choose different orientation. and so on. You can export as PDF. You can export as Excel, which could be quite useful. If I go into these documents, I can actually see. Yeah, before you export, you want to just scale it so that scaling is done correctly. This is your single line diagram in Excel. Okay. All right, so this would be part related to your single line diagram in your system specification. This substation section will be carried out in your SCD file. Again, you can export and save it as SSD file. Now with that, we completed system specification, and we'll go into the system configuration section. Now, do you have any questions in regards to how to draw a single line diagram and how to allocate logical node, basically how to do system specification? If you have later, you can put it on the chat here, or you can send me an email with your question. So with that, I will conclude the single line diagram, and we'll go to data flow engineering. Basically, data flow engineering deals with these tabs. So communication engineering with ID, services, subnetwork, access point, communication diagram. You can draw single line, you can draw a diagram of your COM blocks. Data flow engineering, how to create data sets, reports, GUS, publishers, subscribers, sample values. And we'll learn two ways. I will show you this traditional way, which to me, it's not that it's easier. It definitely is not complicated. It's very intuitive, but it's faster. I can guarantee you that you will be able to fully understand what's in these tabs. All you need to remember is that you are going from left to right, and every tab might have sub-tabs that have something to configure, or they have some important information. So let's make a break here, 15 minutes break, and we'll go on to data flow engineering that we can hopefully complete today. If not today, then tomorrow. But this is the essence of your system configuration part, and you will see that it's fairly easy to do it. Actually, I will leave this type of engineering that is using visual drawing for you. I will take you through process of using these tabs, which is extremely easy, and give you all the information that you need. So I'll stop here, and I'll see you in 15 minutes at 11:15. Thank you. Okay, we continue. We'll continue with our system configuration, and I'm going to open up that is number 4, data flow diagram. So objectives here is we can use the same project. We don't need to create new projects. And we'll now start to import ICD files. We instantiate them. We'll start with the configuration of the network. We'll add a subnetwork. We'll allocate IED access points to subnetworks. That means basically we'll connect IEDs to network. We'll set all communication parameters, IP addresses, net masks, and so on. And then we'll start the data flow engineering. We'll add and configure existing data sets. We'll add and configure goose control blocks. We'll add and configure report control blocks, one log control block. We'll add sample value control block. And then we'll start configuring client and subscribers to control blocks. And we'll show the visual presentation of the IEDs. We'll draw server client, publish a subscriber connection. And finally, we'll export SCD file. In the final step, you will take that SCD file, will import into the ICT tools. This is basically our goal. Our goal is to set all these IEDs, to define their data set, control blocks, and to connect Goose publisher, sample value, publisher, subscriber, and client server MMS. That will be the final look of our exercise. And again, same type file types: ICD, IID, CID, SSD, SCD. And we use the same engineering flow from ICT tool. We generate ICD files, we import them into system configuration tool. I will actually do this part as well using, understand you have Schweitzer relays that you use. So I will use Schweitzer software to basically generate some ICD files. All right, so we'll skip this new project and I'm going to use the same project. This particular presentation is taking you through the use of data flow diagram, but I will actually show you how you use tables, and then we can show data flow diagram and you will understand everything. So we are done with single line diagram. We map logical nodes. That part is done. Next section is communication engineering and IEDs. Obviously, right now I have only one virtual IED, so I'm going to import some IEDs. And this time I'm importing real IEDs. So I'm going to first open the accelerator architect, and I'm going to create a couple IEDs. So I'm going to, I think you mentioned 311. I'm just not sure if it comes in edition 2, but we'll see. I'll add this device and I'll add one 751 feeder protection relay. And all I'm going to do is I'm going to export ICD file. And we're going to put it in the same directory in the training. So Matrix Knowledge Builder. Gonna drop them here. So this was cell 311, L, and I'm going to export cell 751. So first of all, I'm going to import these files. I'm going to import cell 751. And as I'm importing them, they come with a template name. If I try to import, I will get an error saying that I cannot use that template. I have to instantiate. So I'm going to call it cell 751. So this file is now imported. I'm going to add one more file. I'm going to add 311. Oh, this is edition 1, so I can't import edition 1, but I'm going to find this file that you will find in your I can add this ABB file, I guess. And I can add Schneider P446 P1446 P446. I'm going to try to add one more file from Nari. That's a Chinese PCS 902. And let's see if I have a merging unit. Merging unit. I can also add one more generic file. So you obviously start adding your IDs. As you can see, here they are listed one by one with their ID models, logical devices, logical nodes, and so on. So the first tab is communication engineering tab. We're going from that tab left to right, and we need to add, we need to answer the bottom tabs as well. Now, the communication engineering tab has a bottom ID tab that lists all IDs. You can see their edition, their ID within the project, configuration version, type, and engineering rights. Engineering rights describe what kind of configuration process I can add with my tool. full engineering rights means that I can perform the entire configuration process. Some IEDs might be blocked for any editing, then this engineering right would be different. In addition to all these, here I have option to duplicate ID, to rename ID, to add client or add ID. I'm going to add one client so that we can have client server configuration. I'm going to call it generic client. And that would be enough of the IEDs. So again, on the top side, you can do some action with these IEDs. You can add generic IED file. You can add any other IED file, add client, rename, duplicate. Update means update the new version of ICD file to any of these. You just select the IED and you perform the action. You can also export IED into ICD format. The next tab at the bottom is services. Services tab is something that you don't configure, but it's very important because it lists all the capabilities. Remember, yesterday we talked about services. And these are the services listed for each of IEDs, and they describe capabilities. SEL Matrix will use these capabilities while performing configuration process. So for example, it will find that this ABB relay, I think that's 615, can actually be Goose publisher and can be, sorry, Goose subscriber and could be sample value subscriber. So it support process bus with maximum attributes of 6,000 and maximum of 100 Goose messages. Okay, each Goose message up to 6. Maximum number of data set is 100. Maximum number of attributes inside the data sets is 110, and so on. This is just information that is important for SEL Matrix because it will respect these capabilities. It won't do anything that is not allowed. For example, here, this client, generic client, does not allow any dynamic association. In other words, it doesn't have a capability to allow connections. It can make connection, but it cannot accept connection. It's not server. It cannot. Therefore, this is blocked here, and throughout the configuration, SEL Matrix will use this information to block all these actions. So again, the services list capabilities of relays, what they are capable of. Subnetworks are your basically network in your system. Every ID comes with some predefined networks, and I'm free here to delete networks that these devices came with, and I can actually define my own network. So I can define here first network. I will call it local area network LAN _A. Protocol will be 6150 MMS and Goose, and bit rate I can put 1000 or 1 gig. Here are some description. This is station bus LAN A. Oops. This is station bus LAN A. Okay, and I can add another network. I can call it LAN B. Same 6150. This is just to designate what kind of protocol. It's got nothing to do with configuration. Again, 1 gigabit, and this is station bus LAN B. If you are doing PRP, you can later configure. So basically, I define 2 networks, LAN A and LAN B, redundant networks. That is under communication engineering, subnetwork tab. Access point are a table that describe to which network your IDs are connected. Okay, so right now they're shown to be not connected to any network. These are their access point. They can use any designation they want. You usually don't change that designation. And these are the IDs: ABB client, generic ID, merging unit 446, NARI cell 751, two virtual IDs. So here, ABB, I can say that I'm connecting to LAN A, and I can connect them all to my LAN A network. Before I do that, I want to do one thing, and that's I want to assign IP addresses. So the rule is, if you want to change the IP address, if you want to assign IP address, then you have to do it by having ID disconnected from any network. And that makes sense, because once you connected to LAN, you're not supposed to change IP address. If you want to change IP address, you need to disconnect ID from the network and make a changes. So I'm going to use IP address 192.168.1.1 with subnetwork 255.255.255.0. That's LAN C type network. And I'm going to go and give other IDs IP addresses. I'm just going to number them from 1 . So I'll purposely leave this to 1 so that you see that SEL matrix keeps track on IP address conflict. As you can see, I have 2 orange. That's because I'm using 2 same IP addresses, which would be illegal. As soon as I change address, this will change. Also, I don't have subnet mask for this ID, so I will change. If there is a gateway, you would add gateway address, for example, 192.168.100, and so on. If I need to add UDP or TCP port, I will add it here. Now, when I have IP addresses allocated, I can go and connect them to the network. And I'm going to connect them all to LAN A, because SEL matrix also looks where the IDs are connected. If they are connected to different networks, they will limit. This is redundant, so LAN A and LAN B. If they are connected to different networks, then SEL matrix will not allow, for example, goose messaging to be configured, because you cannot send goose message from one to another network. And this is also. Now, for those who are come as redundant, you might choose the type of redundancy. And it could be failover or no redundancy. It could be HSR, PRP, or RSTP. So I'll leave this virtual ID as a PRP, and I'll just make these regular or non-redundant IDs. If they are non-redundant, you don't even have to populate this none. So, but I'm just gonna, for good housekeeping, I'm gonna assign that they are not connected to any redundant networks. And again, if they are redundant, they would come with 2 access points, and 2 access points would not be able to connect to the same network. As you can see here, access point 1. If I leave A, I will get an error. It has to be B. When I complete that, I save this configuration of IP addresses. Now here, router master clock or KDC, if the IDs act as switches or routers or master clocks, you would normally check these boxes. So you can connect ground clock, ground master clock, you can connect router and present them into 6150 configuration. All right, so just going back, single line diagram, we completed logical nodes and we went into configuration process with communication engineering. We imported IEDs, and IEDs come with their access points. They might come with IP addresses and other sections configured, but template file usually don't have that. So when I imported IEDs, I checked their services, and this is just information. You don't need to worry about it. There is nothing to configure here. There's just list capabilities of IEDs. The next step, subnetwork, is where you define your networks. If you run station bus and process bus, and I'm going to add here another subnetwork, and I'm going to call it process bus. It's going to be 61850, and it's usually 100 megs per second. Okay. And then one of these IDs. So this is where you define your network: station bus, redundant station bus, A and B process bus. If I want to add process bus to be redundant, I will have to add another subnetwork. But I'll skip that. And I'm just gonna add here that this is process bus. Okay. Access point, again, is list of your IDs. And obviously, some merging units, they come as in different networks. So I will assign this to process bus. Now, to be able to subscribe, I would need to have another ID to process bus, but I will come to that later. Okay. So this is my communication engineering. Again, IEDs, services, subnetworks, networks, and connection of IEDs to networks and allocation of IP addresses. And this is done. Then I go to communication engineering. Communication engineering is basically allows you to draw communication block diagram, how IDs are connected. And usually you have switches. Nowadays, switches can be imported as IDs with their ports. But if you don't have IED switch ICD file, you can rely on options here on the right side. You can add generic switch, and I can make it 8-port switch called switch A, LAN A, switch LAN A. And it's here. Now I can add this switch here, and I can connect my IDs to that switch. Obviously, your network would be more complicated, so you would have more switches. I will call this switch LAN A_1. Again, 8-port switch. And you would have something like that. And obviously, you would have more switches. I'm just going to create a small ring. So this shows a ring. I can connect other IDs too. So again, this is to show your communication block diagram with your switches. And here I can also, on the next communication diagram, bottom physical connections, I can actually change connection type. If this is all fiber optic or 100 base T, that it is copper, let's make it 100 base T. Or you might have some fiber optic. And so on. And the plug is, here would be RJ45. Here it would be, for example, LC, and so on. So this is just a nice housekeeping to describe what kind of physical connections your ID come with. And as you notice here, as I'm adding these IDs, I'm getting cable numbers that can help me in building my cable schedule. All right, so that's it for the communication diagram. This is not mandatory part. It is optional part. You draw your communication block diagram and you define cable types and termination types. The next section is data flow engineering. And data flow engineering has all these tabs: data set, report control block, clients, goose control block, goose subscribers, and so on. And I will configure them going from left to right. Here are the list of IDs that have data sets. Obviously, I'm here missing some IDs, and that is because some of my IDs listed here actually come without data sets, and that's fine. If I want to make sure that I have all IDs, here in the add data set, I have list of my IDs, and I can add data sets. They will show up here. So let's go one by one. First of all, we have AA1, C1, Q1, 1A1, which is ref 615. And this device comes with the two data sets. One is called Goose data set, another is called security. Okay. It also says here that there are two members of this data set, and there are 110 allowed. So I'm using only 2 out of 110. Also, on the left side, for this ID, it says that it has 2 data sets, but it also says that 100 is allowed. That means that I can add my data sets here, and that's what I'm going to do. How SEL Matrix knows that there are 100 allowed and each allows 110? Well, basically, it knows based on the services. Remember, we said that SEL Matrix will respect what IDs are capable of. Here, ABB Ref 615 allows 100 data sets, each with 110 elements. For that reason, in the data flow engineering, I have indication that hundreds are allowed. And I can add another data set to this ID. I'm going to choose location. You can drop data set anywhere, but I'm going to keep in logical node 0. And I'm going to call it exercise data set for Goose. That's first. As you can see, it shows up in the list of data set, but it is in orange color. Orange color indicates that something is wrong. Well, what is wrong? This data set currently has no elements. The STL matrix indicates that we should probably populate data set with elements. Now, before I do that, I'm going to create one more data set for this device. And I'm going to call it data set for reports. And now I'm going to go and I'm going to populate the first one for goose. At the bottom, I have the ID model with all ID information, model, and all logical nodes and their data elements. And what I'm going to do is I'm going to actually go into the control logical device. I'm going to look for X switch or XCBR. Let's do XCBR. And I'm going to look for position of the breaker. And I'm going to drop STVal. That is the double bit integer that describes position of the breaker, whether it's open, closed, intermediate, or in wrong position. And I'm going to add interlocking for enable open. Now, if I want more data elements, I would actually go and map what I find interesting for this data set. And this list depends on your requirement. Usually, these elements carry some protection-related functions, whether it's operate or, in this case, breaker fail, block information. You can add virtual points, trips, and other protection events into this goose message. Now it's no longer orange because it's not longer empty. Now I'm going to do the reports. I'm going to, for reports, I'm just going to grab some information. Or, you know, I can actually go into the MMXU if there is measurement here. MMXU, I can find this phase voltages. And I can pick magnitude of AB and magnitude as a float point of BC and magnitude of CA. Maybe this voltage phase A, voltage phase B, and voltage phase C. Obviously, you can also grab the entire data object, and if you grab the entire data object, you will get all this complex data attributes of the phase voltage. But this time I'm making this functional constraint data attribute type data sets. So these are my two data sets of the ABB. And I'm gonna look what's on the merging unit as I expected. Merging unit comes with 4 voltages and 4 currents. That's your process bus. Nothing to add here. P1446 has this high performance data set. I might add, because this ID also allows 100 data sets. There is also this 751 that comes with all these predefined data sets. I'm sure you are aware of these data sets. 1522 allowed. The IDs that I don't have here are the IDs that don't have data set. So generic IDs doesn't have a data set. For that reason, I'm going to add exercise data set number 1 for Goose. And I'm going to add one more for reports. And I need to populate them. The first one, I'll just grab position of the circuit breaker. That's for Goose. And for reports, I'm going to grab this MMXU. Let's say current float value of the magnitude for A, for B, and for C. All right, so I got these two data sets. Another unit that doesn't have any data set is this NARI relay. So I'm going to call this exercise data set for Goose. And I'm going to add some information, maybe enable open interlocking condition and enable close interlocking condition. And I can also add another data set to this relay. For reports. And let's add this power to it. Okay. So right now I have just virtual ID. I can also add one more data set for this and pick location, or maybe some protection elements. Time over current, operate general. All right, so some protection element that would usually be tied with your trip. All right, so I have quite a few data sets that I inherited from relays and some that I created on my own. I will also create one data set for this Schneider. Breaker fail, operate. So in the data set engineering, your goal is to go device by device and make sure that data set, content of the data set, which is represented by these data set elements, is what's required by your functions, whether your protection function is utilizing Goose or some other system function like interlocking or load shedding or any other system function that utilizes Goose messaging. Or if you are reporting to HMI, make sure that you populate points that are of interest for your HMI or later to your control center. In most cases, you will rely on data sets that are already populated, because they usually carry information of the interest. For example, this buffer report dataset 01 of the cell 751 has all measurement values. Math variables, your internal logic results will be stored in these. Breaker status and targets are already here. Counter values are already here, and so on. So in reality, you might not need to configure your data set, but by no means you are not limited. If SEL matrix allows you to create data set, that means that Relay accept custom data sets. And if you understand 650 well, there are some features of the custom data sets. And that's that data sets created by an ID can be seen in some cases only by that ID. So if you want to kind of hide information from one ID, you can configure so-called dynamic data sets. All right, so once you finish your data flow engineering, you are ready to do Goose publisher subscriber, process bus publisher subscriber, and client server connections. So I will start with MMS client server, because that is what's first on the tab. This report control block is basically a tab that lists all control blocks that are designed for the client server connections. Okay, some IDs come with predefined data sets, with predefined control blocks, and some don't. Obviously, you can see that this cell 751 has these buffer report control blocks and unbuffer report control blocks ready to be used for your client server communication. And what they usually do is they tie the number of control blocks based on number of data sets. So here, as you can see, there are a certain number of data sets in cell relay. And for that reason, there are the same number of control blocks. You can, for one connection, you must have one report control block. So if you are reporting points to HMI client or gateway, you must use one report control block. That report control block cannot be used by two clients. That's illegal. And SEL Matrix will not allow you to do it. Also, one report control block can have the same data set. This is not illegal. For example, this buffer report control block is already tied with this data set, which means that ICD file from the cell relay, and that's the case for most of the relays, it already comes with populated data sets, with control blocks, pre-configured control blocks, and with control blocks tied to data sets, ready to be utilized for client server or for Goose messaging. So this buffer report 01 is getting data sets BRD set 01, and that BRD set 01 has all this measurement. In other words, cell ICD file already prepared this communication so that it can be established without even any configuration. And I was saying that one report control block is for one connection. However, one or more report control block can use the same data set. So I can make this 02 as 01, and that would not be illegal. Okay? You would just report to different client. And that will be the case if you have multiple clients that want to see the same information, then you would share the same data set across different control blocks. Okay, so I do have for cell P446. For P446, I do not have the data sets allocated. So I'm just going to grab available ones for a couple of them, and I'm not going to utilize all of them. For buffer per control block. Okay. So these 4 to 6 are ready for client server. This ABB has one data set tied to security. And I said I can add report control blocks. And some relays, they say, you know what, I do not have predefined control blocks, but feel free to configure as many as you need. In this case, ABB allows 160 control blocks. So I'm going to go and create a control block for this device. I'm going to call it my report control block. Or actually, I'm going to call it exercise control block for Goose. Actually, we are in imports for reports. Let me just copy this. Okay, now this is asking me to grab a data set. So I'm going to grab data set that I already created. I'm going to grab this data set for reports. In other words, I am creating a connection with a future client that will, through this control block, read information found in exercise data set for reports. This data set's here. That will get these voltages. Okay. So I got one for ABB, I got few for Schneider, and I have already predefined for cell. I'm going to add more for this generic ID that doesn't have. And I'm going to associate data set with it. I'm going to add finally for this virtual ID. And I'm going to also grab a data set. Well, I'll use that data set for Goose, doesn't matter. Now, once you have a data set, you need to go through these tabs and make sure that everything is configured. Usually pre-configured. I'm going to go to these parameters. Report identifier, when I see online a report, I'd like to see some ID. So I'm going to call this one report 01. Data set is data set for reports. Configuration revision is a number that is a unique number that represents this content of this data set. 1001 means it's just a number that starts numbering. You can start from basically 1 here. Doesn't really matter. But if you change the data set here, if you change this data set by removing or by adding more elements or by changing order, this will get incremented so that client that receives this report knows by checking the configuration revision, it will know that there is something new inside that data set and that information that it receives might not be correct. So client will also have information about this configuration revision. It has to match. If it doesn't match, many clients will reject these reports. This is to keep track of the content of the data set. Integrity period means if there is no changes in the data set every 5,000 milliseconds, the entire data set will be sent to the client. Are these buffer reports? Yes, these are buffer reports with buffer time 400 milliseconds. They're indexed. That means they're going to go and be numbered 1, 2, 3, 4, 5. When reporting starts, you want to have unique number allocated to every report. Instances, how many of these instances online will show up? 2. That means that in online version, there will be report control block 01 and 02. What triggers cause this data set, this report control block to send this data set? Well, data change, change, and here data update, not periodically, this integrity, or general interrogation. General interrogation is if client requests data sets to be reported, it would be reported. What other information optional fields? Sequence number, timestamp, content of the data set, reason why this happened, whether it's data change, quality change, period, or general interrogation, and so on. These are additional information that will be tied with report. So I have created report control block for all of these, and I just want to make sure that I have these triggers configured, and that I have unique identifiers. Now, the identifiers really are not mandatory, but it's good housekeeping. You want to have unique numbers so that you can recognize these. So these are already done here, already done here. He's going to get these optional fields, because tomorrow we'll show how this actually looks online. Cell is already configured. This is, I want to see these. Okay. So once I've configured control blocks, I'm ready to associate these IDs with the clients, whether they are HMI or gateways. And that is the next tab, report client. Now, it's easy to associate. On the left side, you will have your IDs with control blocks. So the same list of IDs, and this is basically the same list with control blocks will show up here on the left side. On the right side, you will have available clients that are known to the project. Right now, if you remember, we have only one client. Maybe I can add another client so that we can differentiate. So going back to report clients, I need to go into the communication engineering. Right now, it's showing up that it's not there. Why it's not there? Because it's not connected to the network with these IDs. SEL Matrix is smart enough to know that in the communication section, in the access point, this client too is not connected to any network, and therefore it cannot communicate with any of the IDs. In order to connect, I would need to give him IP address. And I need to connect to the same network where my IDs are, which is LAN A. Okay, I have here switches that also show orange color, but switches do not have to be with IP addresses, they perform switching. So at the moment, I will just skip this. Good housekeeping would also mean that you would allocate IP addresses for switches and have everything. So now if I go back to data flow engineering, suddenly my client 2 is here. And watch what happens. First, ABB device has 2 control blocks. Okay, and I want to connect first control block with client 1. When I click that, client 1 gives me place where I should drop content of the data set received through this communication. And usually for clients, it is logical node HMI. Okay, and I'll click on. And I'm going to add second report control block to client 2. Now this way, my report control block, top report control block is communicating with client 1, bottom is communicating with bottom. I can also have this report control block because it has two clients possible to connect. I could connect to this, and it will be amended to this table. Now, as you can see, this client 2 is receiving via client server MS following information from ID name AA1C1Q01A1, which is ABB relay, from its logical device MON, from logical node MMXU, instance 1, attribute or data object phase AB, magnitude, floating value. It comes through the report. Now, this is enough information from the HMI to automatically create these points and to understand where they are coming from. That's the beauty of the 6150 edition 2, that has now organized these inputs that come from external resources. In this case, for this client, external resource would be this ABB relay. Okay, once I connect ABB relay to 2 clients, I go to the next device. I'm going to, for example, add to this device, to this client. Next, P446, I can take this first one and add to the first client and add to the second client. Same for the next one. First client, second client, and so on. This is how you build relationship between IDs and your HMI or gateway. You just make a connection. Cell 751, let's add to this. This one has only one instance, so if I try to use the same control block, it won't let me. It says maximum clients are reached. This is because here, cell 751 is saying this report control block with this data set can only communicate with one client, cannot with 2. Unlike that, this report control block saying I can communicate with 2 clients. So let's do 751, few more. And let's have this virtual ID. Okay, this is my client-server relationship. These 2 clients are communicating with these relays based on these checkboxes. Client with ref relay, client with generic ID, client 1 with P446, client 2 with ref with P446, and so on. And it is done. HMI to release MMS client server is completed. If you know what points are coming, I'm just going to jump over these and go to input table. And I can see here in the input table that for every ID, I can see what information they receive. This client one is receiving all these data set attributes from relay AA1C1, from generic ID, from P446. All these points are here. And later you will see how SEL matrix can actually generate point list. Client 2 also. Now going back to report clients, we are completed with that. Now we go with goose control block. And here I have goose control blocks for these devices, already pre-configured. This AA1 device actually already have some goose publisher created. But here it also says that I can add 20 more, actually 19 more, total of 20 goose messages. Second device, 16. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this exceeded number of goose control blocks. If I try to add goose control block for this P446, you will see that is not on the list because I cannot add anymore. But for AA1, yes, I can, and I'm going to add here goose control block 1. Actually, I'm going to call it exercise goose control block for goose. Oh, goose control block 01. And it shows up on the list. Now it's asking me to configure these parameters, and I'll do so. The first parameter is goose identifier. Could be null, but could be also something that makes uniquely this goose message, GCB02. I'm going to do the same with this guy. Change to GCB01. This guy has a data set, GCB02 doesn't. So I'm going to add data set called XI data set for goose, the one that we created. Configuration revision is the same. This is goose. Does it have security with signature encryption? If it has, you add. And then the publishing time. What's the rule for publishing? And again, this is explained in the standard. MAC address. So I'm going to make it unique, 99. Application ID. Again, we talked about it yesterday. If you want to give your zone interlocking application unique app ID, you can do so. No VLAN, no priority, and I'm okay with that. This one has unique IP address, fully configured. P446, let's tie high performance goose with configuration revision, and let's give it MAC address 12. Cell 751, it has this GP data set and goose publisher 01 already configured with MAC address, but I'm going to add another one. Cell 751, I'm going to add in this, I'm going to call it goose control block 1. I'm going to associate this data set, unique MAC address. So far I have 2, 3, 5 goose messages, publishing goose messages. Let me add one more for this PCS. I'm just going to associate goose data set and unique IP address. That's enough. Almost 10 goose messages. Now, who are the subscribers? Well, that's defined in the next table. And again, I have publishers here, all the goose control blocks. And now I have like a matrix at the top. I have potential subscribers. If there is grayed out section, that means that these devices cannot subscribe for whatever reason. Mostly the reason will be that they are not on the same LAN. As you can see, this merging unit is on process bus. Therefore, you cannot receive anything, cannot receive any goose message from LAN A. For that reason, merging unit is not even listed here. Others might have limits, but those who don't are listed here. And look what you need to do. If you want to subscribe to this goose message, you find ID that subscribe, you click on it, and you place this into a section related for that. So some IDs will come with input reference. This is what is done in addition to. Unfortunately, as you can see, this P446 does not have input section. And this is fairly incorrect because goose messages as well as client server messages should be placed in input section. Now, our software indicates that this SCL file has found no input reference. So if you know where this relay accept, make sure you highlight correct logical node. Usually it used to be an addition one LLN0. Same for this cell 751. Here, this virtual ID that we created yesterday, it says, okay, I do have place where I store incoming goose messages. That is input section. So as you can see, it's highlighted logical device that is highlighted and logical node where input section. This is proper way of dropping your goose subscribing messages. It should be in the input. That's the purpose of edition 2. One of the purposes was to address where the subscribing goose messages will be stored. And the standard proposed storing in the input section. And as you can see, some IDs do not care about that yet. And that's the bad implementation. Now, this top button here will help you in locating quickly, filtering out everything, just giving you a place where you can drop your points. So I don't have to worry whether I'm correct or not. When I click this checkbox, I know that this goose message will come to the right place. All right, so subscriber for this goose message is done. We have 1, 2, 3, 4 subscribers. Let's do subscribers for this guy. This ABB is also smart enough. ABB has really good 6150 implementation, perhaps one of the best. So it does have input section. So it does tell me where to drop goose messages. We're going to do that. I'm going to drop this guy here. I'm going to subscribe with cell 751. Okay, so cell 751 will add, actually, once you create, it will dynamically create input. So good job for cell as well. And let's make subscriber for this guy. Let's subscribe with cell 751 and with this virtual ID. So if you look now, let's make this subscription. Let's make this subscription. So here we have now Goose publisher subscriber defined. As you can see, publishers, subscribers. Where you have a checkbox, that means that this P446 subscribed to this Goose message. This 751 subscribed to this message, so does this virtual ID, and so on. Sample value control block, there will be same configuration as for Goose. You have your merging unit with data set with current and voltages, and you have some information to address here. One is MAC address of your publisher, sample rate, data set, security, that's the information I want to receive. And now for the subscribers, it appears that none of these IDs actually have capability to subscribe to. And I know that this ABB has, however, it's not connected to the same network. So here, so I'm going to duplicate this ID. And I'm going to call it copy. And I'm going to add this copy to process bus network so that these guys, let me just add IP address. So this merging unit was, oh, this was incorrect. The process bus should be on different network. So let's call this 9. And I'm going to put this 2. The IP address and sample value or Goose doesn't matter because it's a layer 2. But this is just a good housekeeping. So now in the data flow engineering, in the sample value subscribers, yeah, I have this because this ID supports sample values. How do I know that? Well, I read in the services section here. So if I look at the copy, here it says that is sample value subscriber here. That's how I knew. And so does, so if I want this ABB unit to subscribe to this process bus screen, all I need to do is add to this section. Okay, so that is now completed sample value, control block, and subscribers. Same would be for log, control block. Unfortunately, none of these IDs support, so we'll skip. Now, input table looks bigger because it contains all information about publisher, subscriber, and what type of points. So this is automatically populated and will be very useful when we generate your point list. whether it's through Goose. Here you can see that this is getting Goose messages. This copy is using sample values to get current and voltages from merging units, and so on. This client is getting to reports. So everything is intact. And finally, I have this data flow engineering. Now, what I'm going to do is this is what would be at the beginning. Now, I would like to visualize my work. So I have data sets, I have report control blocks, I have clients communicating to MMS, I have Goose publisher subscriber, I have sample value publisher subscriber. I'd like to see that. So in data flow engineering, what you do is you click on filter dialog and you click on your network. So I'm using LAN A, LAN B for MMS, I'm using process bus. And I'm going to show all IDs. I'm not going to show switches. They are not of my interest. So here I have 3 networks and IDs that are there. Now, if I want to show Goose, I click on throw Goose messages. As you can see, I can see how IDs are communicating. Who is publisher? I can click on the publisher and I can see who's the subscriber. Okay. I can also draw reports. It shows the 2 clients and a bunch of servers. If I want to focus on this, I can see the connection. And finally, I can show sample values. This seems so this is how you visualize your work. Now, you can also ignore these tables here. And that's what presentation is showing. And you can work only of data flow. How? Well, basically, you would have empty space and you would start adding IDs. For example, let's add this and it will show up here. And you would start building from here. You can go and modify your subnetwork. You can modify your access point. You can rename, duplicate, update ID, delete. You can work on your data sets. You can add subnetwork. You can add data set, add reports. All options that we saw on the tables, you can actually do in your data flow diagram. These are 2 options. Again, this is how you visualize. You can click on draw all, and all the publisher, subscriber, and everything will be drawn. Okay, I made a mistake here. It's not LAN B, but it's process bus. And this is the end of your configuration. This is the end of your system specification, drawing single line diagram, doing communication engineering, drawing your network diagram, and doing the data flow engineering with configuring your Goose sample values or client server MMS. When you finish that, you save project and you can export SCD file. Now, there is this validate project option that will list everything that hasn't been completed or has some incorrect or weird things to do. First is it says there's an allocated ID access point switch LAN AAPP1. And indeed here, while doing these IDs, I didn't allocate all logical nodes. Some of these are not connected to any, some of them are not using any configuration. Some of them don't IP address. And that could all work fine. This list is not something that will cause errors. It's just listing some things that you want to consider. For example, this apparently control block, it doesn't have a data set, GCB 02, 03, 04, 05, 7, 8. So yes, when I was doing communication engineering for the Goose control blocks, this P44 had a bunch of these control blocks that are not tied to any data set. So I would, to keep everything consistent, I would have to go and either delete them if I don't use them, or add a data set, or add these parameters. So that is very useful feature that allows you to quickly check whether you have some, you can print this as a report and so on. Now, I'm exporting this SCD file as a training. I'm going to call it training exercise. And this is my SCD file that IDs can import to complete configuration on ID level. Here, important is project report. This becomes very, very handy. I can print out all my important information. What would be important? Well, for example, I would like to see who are Goose subscribers. And here I would have publisher and subscriber, the list. Then I could say I would like to see members of the data sets. And they will be listed here. Here you can edit these. There is there's an option to add your specific information. I believe that is somewhere in, it's definitely explained in the manual. I'll find it. What else? Well, I can draw the com block diagram. I can, we saw single line diagram. I can actually have all inputs to every single ID. So watch, at the top, I have an ID. This ID receives information from all these IDs. So first, you have type of messages, Goose, and then you have source of information. I can go to clients. As you can see, there are 69 pages already generated. So here, this is HMI. And here are the IEDs and points from IEDs. So that can be turned into your points list for testing, especially when you can export into the Excel. Let's see how that looks in Excel. Here, you can keep doing whatever you want, but here are your point list immediately. What else can I do with this? Physical connections, data set with members. What type of information? So you can see this data set, logical device, XCBR position, STVAL, status information, so on. There are 40 pages automatically created. Report designer is where you actually create your logo. Here, this is where you can change and put whatever logo you want to have and some specific. You can even generate some fields here and so on. So that's how you can even create HTML and so on. Here are the options that you can put the charts and add many things. This would be training for itself. You can export this to all these formats. You can email this. You can change colors. You can zoom in, zoom out, change orientation, paper size, margins, scale it, all sorts of options. Okay, and that's how you perform system specification and system configuration with SCL Matrix. Do you have any questions? I encourage you to use this presentation and to try to configure something with your on your own time. There are a couple more presentations that I'm not going to go through, and that deals with some various topics. One of them is how to replace, how to import SSD file, how to import SCD file, how to do allocational logical nodes, how to deal with project reports, and so on. Renaming IEDs, adding. So this is more following what I did. Excuse me. And you can do it by yourself. There is also exercise that deal with compare training. There are sample exercises here. One is how to replace faulty device, how to do top-down engineering. That will cover what I just did, but it will give you step-by-step example how to do it. Replace faulty device. If you are doing maintenance and you need to replace one of the devices, this is how you do it. Okay. All right. So if there is no more question, this would be the end of today's session. And tomorrow we'll jump on SimLab and Discovery. And tomorrow we'll grab that SED file and we'll actually run some live session. You'll see how to configure SimLab Connect times. This is all practical work. Putting SED file in simulation and then later connecting with and troubleshooting with Discovery. There are some exercises that we might not be able to finish exercises, but you have all the resources to do by yourself. You see, you have 13 exercises taking you how to configure a simulator, how to get control, how to operate controls, how to do file transfer, MMS reports, goose messages, how to import contract file and do everything. So plenty of stuff to test. Okay, so that is it for today. Thank you for being here, and I'll see you tomorrow.
Thank you, teacher.
Thank you.
You're welcome. Bye. I'm going to stop recording.